Welcome to the tutorial for creating output from microscopy data in Blender. So this is for creating your final image or for creating animations and how to kind of deal with all of that. So I'll first load like a simple data set, which will be fluorescence data, but this is of course also possible for anything else. So here we have our data, where I will quickly turn up our surface threshold here to make it actually work. We would like to save an image and not just take a screenshot, but actually save the image and render it out fully. So for that, we would first add a new object into the scene, which is a camera. And this is just placed somewhere randomly, but we can now do view, align active camera to view, and we can see that this is actually what we're looking through in our active camera. This is here if you have multiple cameras in the scene, so you can add another. So this also, the add is also under Shift A. The active one will be the one that is clicked here. So if we now go to our camera view here in the other active camera, we see that this is just randomly placed in the scene and doesn't really see anything. While here, our active camera saw what we just set. Then the camera just behaves like an object. It has location, rotation, and scale. But it also has some camera-specific things, such as a focal length. You can also here pick whether to make it an orthographic or perspective view. And of course, you only get a focal length in the perspective. And some other details. But most notably, you can now press render image, and this will then create a final render. Our final render has slightly heavier settings usually than our viewport, and so the view that we usually walk around in, so this takes slightly longer to create our output. But this is how to get to our first actual output. However, I think one of the cool things in Blender is that we can't only make static images, we can also animate our images. And so for that, we have to, of course, look at our timeline, which we have here at the bottom in our layout tab. So right now, nothing moves over time. And that is because we do not have keyframes set, and because this data is one time frame. So what a keyframe is any value in Blender that that you set at a specific time frame to be a specific value. So you do that by pressing I on your keyboard or to press these dots. So if we hover over this and press I, we set a keyframe for the location at the time frame we currently are at. We also want to do this for the rotation. So now we've set at frame 1, these values need to be as they are here right now. And what we can then do is it stays the same over time, but it's no longer yellow because we are not at the specific frame. We can change these values. So for example, if we change X, we've moved the camera and we set a new keyframe. So we press I again. We'll see that we're now over this time series. Put it in the rasterize for a bit quicker. We're moving our camera, so it's interpolating between our two keyframe values. And so this isn't beautiful, so we can delete it with X, delete keyframes, and actually go to a view that's more interesting. For example, zoomed in on our centrioles. So we're now where we want to have our camera. At frame 119, for example, we can do align active camera to view again, and then set our keyframe for where we're currently at. And then our video goes from our overview down to our centrioles. And now we can press render animation, and this will then start to render all of the images in our sequence from the start frame to the end frame. So we can actually make that the end of our sequence here as well. And so in this way, we have made our first animation. And what the fun of Blender is that all of the values in Blender are almost all the values in Blender are animatable. So we actually can also animate the thresholds of your surface masks, or the intensities of your pixels, or anything that is a value where you can hover over it and press I, you can make a keyframe out of, and you can start animating it, which gives a lot of power to just animate whatever you want in Blender. So the other often a case that you can do is, for example, to set a keyframe on the position of the slice cube, where you want to set it, move your slicing through Z over time. So we set a keyframe where it's fully encompassing the volume at the start, and one where it's out of it, almost out of it at the end, and then we make it a lot thinner. And then we have an effective Z slicer, which of course doesn't really combine with our camera. So our rendered animation, if we press render animation, it will arrive here in output. We can see where these files will actually be written. And so for me, standard is that they get written to a PNG, and then I compile them to a video myself later. And the benefit of that is that you can stop it halfway and you still have half the render. All the images that have been rendered, you can just do with whatever you want. You can also set it immediately to go to a video. And that will have to render all the frames first, and then it can compile it into a video, but you do get your single output video. Sometimes we also have a time axis within our data where the data moves itself, and how do we make a nice video with that? So let's exchange our data set here for a data set with a time axis. So delete everything and put in our lightsheet data, and we can see our data move here. So this is nice, and we add with Shift A camera into the scene, and we map it to our viewpoint, and then we can still rotate it a little bit to actually make a little bit more sense. And animate this, so we can set it again, 0 to a specific keyframe, and at the end, at some other place. And the camera is also just movable, so we can also just use any other move command, set a new keyframe with I, and see how it looks. So one thing is that the axes are very big, so I will just, here in the axis modifiers, make them a little bit thinner, and also remove the top. So that will be a little bit more smooth. And then also what's the issue is that our data moves slightly faster than we actually want to, because we only have, for each frame of camera movement, we also have one frame of data movement. So this is not amazing. So what we can do to fix that, we can go into our output settings and look at our frame range, where we have time stretching. So this is the only way currently to change the frame rate of your volume video. I hope to still add something that we can at least also add an offset to the start more easily, because that is right now quite hard. And hopefully at some point we'll get slightly better controls for this. But we have here our old number of frames, and we can go to our new number of frames. So for example, 900, and then everything will move a lot slower. Our keyframes are also affected by the time stretching. So to add more, while this does add more frames of interpolation, you would also still need to move your keyframes. So you can actually move your keyframes with G. And we now have, for the first sequence of time, do a little bit longer, we have our frames moving slower than our actual time because we've stretched the time. So now we can see all of our cells moving slowly while our camera smoothly moves down. You could animate not just the slicing, but also your alpha value where you start. Let's put a keyframe here at 0 alpha, and then we slowly come up to 1. And remember that this is time stretched, so it will take slightly longer. And we can see that there's the transition that we hope. Here, this will actually, in the ray traced, we actually get the conclusion correctly. Okay, so I hope this is clear, but I think that there's still a lot of stuff that you can mess around with cameras and animation. So please, and also once you're in this, there's a lot of extra stuff. You can also change the exact speeds of acceleration and deceleration of your animated values. But this is all, I think, a little bit more in depth, and I want to go just for the basics of microscopy visualization. So I hope that you can also find the tutorials of people who actually do animation to show how this is done. Thanks for watching. I hope you have fun with animating and creating output.